Today is July 24th, and my guest is engineer and writer Brian Potter of the Institute for Progress, where he is a senior infrastructure fellow. He writes the Construction Physics Substack, which is a fascinating collection of essays and posts related to a wide range of topics in engineering, construction, various other topics. Our topic for today is one of those Substack essays, how to build 300,000 airplanes in 5 years. Brian, welcome to EconTalk.
Hi, Russ. Thanks for having me.
A lot of historians attribute the victory of the Allies in World War II to the extraordinary manufacturing capacity of the United States. It's a factoid, is what I would call that. The so-called arsenal of democracy. And as an example, you write the following. Between 1938 and 1943, U.S. manufacturing output tripled as production of munitions ramped up. Over the course of the war, the U.S. produced around 5,600 cargo ships, 80,000 landing craft, 2.4 million trucks, 2.6 million machine guns, and 41 billion rounds of ammunition. Close quote. But the focus of your essay is on another area, the production of airplanes, and you have much to say about it. Here's the opening quote to get us started. Over the course of the war, the U.S. produced around 325,000 airplanes, valued at roughly $46 billion or $800 billion in 2024 dollars. Not only is this more aircraft than what Germany, Japan, and Italy combined produced during the war, it's also more aircraft than have been built for commercial transport in the entire history of aviation. Is that really true? That is such an extraordinary data point.
So that's a rough estimate, but the magnitudes are such that it seems like it very likely must be true. Today we build, for commercial transport, so like, jet airplanes or whatever, we build on the order of like 1,000, 1,500 airplanes a year. So if you just multiply that by the time that aviation has existed as an industry, the numbers are a huge stark. And of course, aviation today is much larger than it was. Commercial aviation is much larger than it was, in the 50s and 40s and 30s before World War II. So just we just don't build that many commercial aircraft. So the amount the industry had to scale up to produce the wartime airplanes was just incredibly enormous.
I was looking at some data. The fleet of, say, the three largest U.S. airlines, United, American, Delta, they have about 1,000 planes each. FedEx, to my surprise, has fewer than that. At least according to the sources I found, a little under 1,000. And yet, in this brief span of World War II, the U.S. produced 325,000 planes. Germany, Japan, Italy, 200,000. So the Allies, the three largest being the United States, Russia, and the United Kingdom, tripled what their opponents produced, and the U.S. did 50% more than the Germany, Japan, and Italy all by itself. One last statistic before we get into some of the details, because this one, there's so many facts in this that I loved. So remember, at the peak of the war, peak of airplane production, 1944, the number you give is around 96,000, roughly 100,000 planes. In 1937, the U.S. produced 3,100 aircraft, 3,100. So they go from 3,100 to almost 100,000. And the 3,100 were mostly small private planes. Prior to the war, the value of aircraft made in the United States was about 1/4 the value of cans produced. That is, the can industry was 4 times the size of the airplane industry, and the airplane industry was 3.5% of the value of cars. So 37, there weren't that many cars, but it just tells you how little and small the airplane industry was. So how did that process unfold, which is what your essay is about? How did the United States ramp up? And I think in the popular mind, we flicked a switch and all of these plants just started making lots of planes. But it was a lot more complicated than that. How did it unfold?
Yeah, it was more complicated than that. And what's interesting is that just the flipping the switch was sort of implicitly what the plan for wartime mobilization was, what they called M-Day in a lot of this documentation, the day when we were going to switch over to a wartime economy.
Mobilization Day.
Yeah, Mobilization Day. And they had sort of assumed that, okay, we'll flip this switch, we will enter mobilization, and all our industry will now switch to sort of producing planes and tanks and guns, and it will just be easy to just transfer over. But there was really it of course didn't work like that, and there was no plan in place for how they could transition this sort of to a wartime economy, producing just huge amounts of munitions and airplanes and tanks in unprecedented numbers. And so I kind of break it in the essay. I kind of break it down into sort of a couple different phases. The first important phase of the scale up was before the U.S. even entered the war, was in the late 1930s, and this was when, it's partially before really World War II even started, but Britain and France were getting very nervous about Germany's territorial ambitions in the late 1930s, and they suspected that war was coming, that war was on the horizon. And so they started scaling up their own basically armed forces in anticipation of that. And so they placed very, very large orders for airplanes and airplane engines with a lot of U.S. manufacturers. Companies like Boeing, companies like Lockheed, companies like Pratt and Whitney. And that initial injection of funding allowed these companies to sort of start scaling up their operations. And even these orders, there was an order from Britain for like 250 bombers or fighters or something from Lockheed, which, by the later standards of the war was very small, but that was like, a huge order, much, much bigger than Lockheed had gotten in its history. And so those initial orders allowed these companies to start scaling up their operations, and in some cases rescued these companies from like the brink of bankruptcy. I think Pratt and Whitney was on the cusp of going out of business before they got this huge order of airplane engines from France. And then so this was part of the initial scale up, and then so the industry itself had started scaling up its operations then, but the U.S. armed forces weren't really preparing to build huge numbers of airplanes yet. As late as kind of early 1940, you have armed forces saying, well, maybe over the next 5 years we'll build 5,000 airplanes, 10,000 airplanes, something like that. Very, very small numbers compared to what was ultimately built. But then when Germany invades Western Europe in sort of later of 1940, then this all of a sudden this becomes like an emergency. It's like, oh crap, this is going to be we're really going to build a lot of airplanes, a lot of munitions. And so after this is when Roosevelt goes to Congress and he says, I want to be able to build 50,000 airplanes a year, which was like a preposterous number, more than anything, roughly as many airplanes as the U.S. had built since the airplane had been invented by that point, including all small little tiny planes and things like that. And so after that is when the U.S. mobilization started to scale up and get into gear. And then when Japan attacks Pearl Harbor, then Roosevelt goes back to Congress and demands even larger amounts of airplane production, and sort of mobilization kind of scales up further. So those are kind of the three stages when the U.S. began to kind of transform its aircraft industry.
And it's easy to forget. I always think, well, the U.S. enters the war in 1941, but Pearl Harbor is December 7th, 1941. So really the U.S. enters the war full bore in 1942. And so we're going from this preliminary phase where the U.S. is building planes for Britain and France to 42, 43, 44 going insane. And as you point out, most of the new aircraft factories and their size and complexity is extraordinary. But the new factories that were built, some were expanded, but there were an enormous number of new factories that had to be built. They were built by the government as you describe it, government-owned, contractor-operated facilities. Why? And was that a plan, or did that just come about?
So they initially hoped, the initial hope in the scale up was that sort of the industry could like scale up its operations itself. They could, fund the construction of their new factories based on the new orders that they were getting from the government. And so the initial phase of sort of this aircraft mobilization was sort of making it easier for the industry to sort of finance its own scale up. And so they did things like change the amortization period for factory construction and change the amount of profit allowed in government contracts to make it easier for these things to sort of build their new facilities. But it kind of eventually became clear that the size of the scale up was so enormous. And also the fact that the methods of production were so different than what had previously been used. Where previously these aircraft were essentially kind of built by hand in like a craft production process, basically the same way that cars were built before the invention of the Model T. So you had these things assembled in place by hand, not using interchangeable parts. So every aircraft was like a little bit different. But then you had to build the aircraft, and the numbers were necessary. You had to build in something called line production. It's like an assembly line where you have material flow and a series of sequential operations, and the airplane gradually gets built together piece by piece in that fashion. And the facilities that were built to make airplanes in this fashion were not the sort of facilities that were actually all that useful for building airplanes in non-wartime conditions. And so we're building all this infrastructure that the industry couldn't really use in peacetime. And so for reasons like this, it basically became clear that the government needed to sort of finance the construction of all this infrastructure. And so they ended up building all of it, and the government, and that these contractors would come in and operate it. And you see this kind of across the board in wartime mobilization, that most of the facilities and manufacturing plants and things like that for building the armaments were this sort of government-owned contractor-operated model.
They were really big.
Yeah, these really huge, enormous plants, millions of square feet. The factories that they were building were like the largest factories in the world at the time when they were building. I have one image in the essay that shows one. I think it's a Dodge plant in outside of Chicago, and it's roughly the size of the lower part of the island of Manhattan. It's this truly enormous factory. Millions of square feet. Just cranking out huge numbers of airplanes. I think that factory, or another similar factory, actually later became O'Hare International Airport because the facilities were that large
and not that useful afterwards. So they had to figure out what to do with them. So the Dodge Chicago plant was 6.3 million square feet, and you think, well, I don't know, what is that? And you've got a picture that captures it. ChatGPT tried the following image. 10 New York City blocks, say from 50th to 60th Street, and then between 2 avenues, 7th and 9th Avenue. It's really, really big. And then the Willow Run plant, I think the assembly line, part of that was a little over a mile long, 1 mile. At its peak in 1944, this is from another website, they were making a B-24 roughly every hour. So just close your eyes and think about a B-24 bomber, and in a minute we'll talk about how complicated it is to make one. But it's rolling off the assembly line 1 an hour, a fully finished, flyable bomber. And by 1945, the Willow Run plant was producing 70% of its B-24s in 2 9-hour shifts, with pilots and crew members sleeping on 1,300 cots as they waited for them to roll off the assembly line. So they'd finish a plane and they'd go, hey, you guys over there, wake up, come on, fly out of here. Because they had like a landing strip right outside them, right, not surprisingly. And that's just kind of extraordinary.
Yeah, the output was truly extraordinary, and it ended up resembling Ford with its Willow Run plant ended up resembling car manufacturing, where you have this assembly line, you have this sort of continuous stream of products being produced by these factories, and getting to that point with aircraft manufacturing was incredibly difficult because an aircraft is way, way, way more complicated than a car. It's much larger. It has many, many, many more parts. I think a mid-sized car at that time had something on the order of 5,000 parts. These aircraft had closer to 150,000 parts, plus hundreds of thousands of rivets, plus all the parts in the engine and all the equipment that they had to attach to the plane. So it's much, much more complicated. And a car could kind of be built with these fairly heavy, robust pieces of metal that you stitch together. But an airplane was a very, very high performance piece of equipment. So it had to be sort of operating at a much higher level of performance, so that the horsepower of an aircraft engine was much, much higher than say a car engine. 1,000 to 2,000 horsepower compared to say 70, 80 horsepower for a car engine. All while being having to be much, much lighter proportionally than the car engine, and it was operating at a close to its maximum performance level for almost the whole time that it was flying, unlike a car engine where it only rarely kind of reached its maximum level of output. And because it had to be, this thing had to fly through the air, these airplanes have to be as light as possible. So it's all stitched together using these really, really thin pieces of metal bent into kind of these complex curves, which are very, very, needed to be produced with a lot of precision, much more precision than in sort of car manufacturing, and stitched together using these kind of complicated assembly methods. And so achieving that level of output and continuous production with these really complex, precise products, large and complicated products, was very, very difficult for these manufacturers, and it took them a long time to be able to do it.
And it's most of the workers are not skilled. I'm wondering how many skilled. Each plant must have had a significant number of people who had a very sophisticated sense of this production process. Describe it's complicated. The way that the metal is bent in certain shapes. It's not just stamped out, delivered, and then attached by riveted together. Those people who are doing that piece of it must have, I'm sure there's a lot of learning by doing. I'm sure they got much better at it as the process went on, but that must have been a very difficult process.
Yeah, it was incredibly difficult. So kind of, as I understand, kind of what you see is that for these aircraft manufacturers, these companies started as pretty small operations. I think the average of the 5 largest aircraft companies that ended up making the lion's share of U.S. planes during World War II. I think they started the war with something like an average of 1,000 or 1,500 employees apiece. And some of them were even smaller. Some of them were over only, a couple hundred employees. And these grew to sort of enormous organizations of hundreds of thousands of employees. And so what you kind of saw is that the executive team that kind of ran these companies, they tended to be, they stayed experienced, as a group of people who were very experienced, who had a lot of knowledge of how to build these aircraft. But the actual, factory line workers, those were just huge numbers of new people, lots of them women. There ended up being almost 500,000 women working in airframe and aircraft engine assembly plants. But overall, it was people who had never really worked in aircraft assembly before. And so you had this was another big and difficult transition where you're moving from basically a process where the knowledge of it is embedded in like the factory workers' heads and the factory foreman and the people actually doing the assembly, to a situation where the knowledge is embedded in the process itself, and you have these things being put together by relatively unskilled workers who did not have a lot of experience building airplanes or building anything at all, or having manufacturing skills, traditional manufacturing skills. And so that was another very big, difficult transition that these companies had to go through to be able to produce these airplanes in huge numbers. One of the sources that I read said that to a very large extent, the workforce that was available basically chose the production system, because the workers that you had to build these airplanes were basically unskilled. It was lots of women that weren't as physically strong as men. So they basically had to design a production process around the workers that you had available to staff it.
And of course, there were a lot of women involved because a lot of the men were fighting in the war. You talk about the extraordinary, I mean, it's just hard to fathom the extraordinary nature of the inspection process because there was so little margin for error. You write that an aircraft engine and its constituent parts might undergo 70,000 inspections during the manufacturing process. When Ford engineers visited a Pratt & Whitney factory to learn about aircraft engine manufacturing, they initially thought the job, quote, looked easy, and that the quality and precision requirements were excessive. But as they studied the engines, their performance requirements, and the need for reliability, they changed their minds. And at a Ford aircraft engine plant that eventually employed around 15,500 workers, 3,000 of them were inspectors, close quote. That is, basically 20% of the workers were simply making sure that the other workers were doing their job accurately. It's incredible.
Yeah, it goes back to what I was saying previously, that these are really high performance, very precisely machined, precisely built, pieces of equipment operating at like very, very tight tolerances. So you have situations like if there was even a scratch on like a gear or like the wrong piece of equipment or something, that thing might have to be thrown out because that scratch might create, a place where stress could concentrate. And these things were operating so close to their limits of material strength that you couldn't have these sources of like stress concentration. And so another sort of example of how difficult it was to sort of get these things built was like for a traditional, something like a car engine, you would sort of, once the engine was assembled, you would, turn it on and run it and do a sort of brief breaking in period. With an airplane engine, you would run it for a very long time to make sure that it worked. And then after it had run, they would have to disassemble the entire engine and inspect every single part to make sure that it hadn't like worn unnecessarily. And then if it had, worn unnecessarily, there was too much wear on a single part, they would replace that part, reassemble the engine, run it again, and then keep, checking to make sure there was not any undue wear or any sort of problems with any of these engines, because they were operating. This was basically at the limit of like piston engine technology. And so you were at the limit of sort of what this technology could do. So your margin of error was very, very slim. And so it was just, inspections and quality control became incredibly important to get these things produced, in the battlefield in working order.
I think a lot about Southwest Airlines because has been such a successful company. They did many clever things, but one of the clever things they did is that they only had one kind of airplane, and has some drawbacks. But until recently, I don't know if it's still true, every plane that Southwest flies is, I think, a 737, but it doesn't matter. It's one kind of airplane. And one of the advantages of that is that when you turn it around, when a flight comes in and then people get off, then the plane has to be prepared for the next group, and the luggage has to be taken out, and the plane has to be refueled, and the food has to be put on, and the bathroom's cleaned. You get really good at it because it's the same plane every time. And you don't have 5 or 6 different models and different types of planes to try to remember and figure out, this door's over here and that, and so on. And one of the things that you write about in this essay that's so extraordinary and was such a challenge is that these planes were modified constantly for performance improvement in battle, and then that reverberated back onto the manufacturing process. So talk about that challenge, because that is, I think you say the P-47 had 5 major design revisions and numerous smaller updates. And these are things like a redesigned rudder, more cockpit armor, more powerful engine, longer wings to hold more fuel. So they're constantly changing the design of the plane to improve its performance. But then the production process has got to almost not start from scratch, but that's an incredible challenge.
Yeah, this was another thing that was very, very difficult. So in traditional, mass production manufacturing, you try to at some point freeze your design. So you figured out what is it going to build, and okay, at some point we're not going to make any more changes. This is a thing that we're going to build until the next major revision or whichever, which may be in a year, 2 years, 5 years, whatever. And they would just build that thing over and over again. And didn't always strictly work like that. You would make sometimes small changes on the as to models if problems reveal themselves. But in general, you're trying to sort of lock your design and just not introduce any more changes. And they tried to do that with aircraft manufacturing during the war initially, but it basically proved not feasible because these things, they had to be constantly improving their aircraft because the enemy, of course, was constantly fielding better and better airplanes. And so they kind of had to make sure that they could field a competitive, equipment and weapons. They had to sort of be improving their own aircraft to kind of keep up. And so, they're constantly introducing changes, problems that they've identified in the field that they have to go and fix, and performance enhancements and specialized versions that are adapted for specific missions and things like that. And so you're having this huge flood of constant changes coming into the factory as you're trying to produce these things in huge numbers. As you're trying to scale up your manufacturing, you're also constantly changing what it is you're actually building. And to do something like that, you need what's called a very good production control system, which is basically a system of information management that tells you what to build and when to build it and who exactly is going to do what task and what task that is and how the material needs to move through your manufacturing operation. And that was another thing that these companies had to sort of develop over time, because when you're building really, really small numbers of airplanes very, very slowly, you don't need very good production control. Everyone can kind of just keep the knowledge in their heads. But when you're building, hundreds of thousands of these things, and what you're building is sort of constantly changing, you need a much, much more robust system. And so these airplane manufacturers kind of had to invent that along with everything they were else inventing about the production process.
Here's an example, quote, flight testing of the B-29 resulted in 900 design changes before it even began large-scale production. When Chrysler manufactured the Cyclone engine for Pratt & Whitney, it had to incorporate more than 6,000 changes over the course of the war, resulting in nearly 50,000 separate change orders. North American's B-25 first flew in 1940, but over the next 5 years, the company spent roughly 2 million engineering hours redesigning the aircraft and incorporating changes. End of quote. It's really an unbelievable thing. I'm curious how you came to write this essay and accumulate this knowledge. And how long did it take?
I'm all just very interested in manufacturing and what it takes to produce things, and how we get sort of better at producing things over time. And that's kind of a through line to a lot of the essays and topics that I write about. Is sort of a very broad summary is how to build things and how to build things the better over time. And so this was just a topic that I came across, and I realized I didn't know that much about it, and I wanted to dive in more deeply. I don't remember how long specifically this one took. Usually it takes me a few days, a week or so, maybe of research, and then a few days to actually write the post. And sometimes if it's a very, very involved one, it takes longer. This one I think is about 5,000 words, so it probably didn't take that much longer than that. So probably on the order of 2 to 3 weeks, I would say. Not maybe working solely on that, but roughly about that amount of time.
Yeah, I would say about a year. I would have said maybe more. The thing that there's an emotional piece to this that, of course, the numbers can't capture. When you hear about 2 million engineering hours, when you hear about women coming into a factory who've never done anything in manufacturing before, obviously the task of airplane engine production is tame compared to fighting in the Battle of the Bulge or Iwo Jima. But there is something heroic about this experience that must have been extraordinary when they turned off the lights and the war ended. I think about one of my favorite museums in the world is the Churchill War Rooms in London, and if anyone listening hasn't been there, you should check it out. It's the quarters, the living quarters where the British leadership, Churchill and his ministers and military officials would meet during the Blitz. When the Germans were bombing London, they would go underground and they would sleep, eat, and plot troop movements and other things because they couldn't stay up above ground safely. And when the war ended, they just turned off the lights and left. And somebody realized that people might want to see it. I think that's the story anyway. At least that's the way I remember it. And so when you go there, there's a certain ghostly, haunted aspect to it. You're struck by how humble Churchill's bed and desk are and the whole thing. The kitchen, I mean, it's unimaginably simple and unluxurious. And then there's a map room. There's a big room where obviously communications were coming through and troop movements were being plotted and kept track of. And then one day, after Western civilization hung in the balance, they turned off the lights and came up and didn't use that place anymore. And that feeling of what that must have been like was unforgettable, I'm sure, for the people who experienced it. And similarly, if you worked in a factory the size of Lower Manhattan, day in, day out, doing what you thought was necessary to save at least your country and maybe Western civilization, the world, as you knew it, that idea of that plant, I mean, it's just the level of intensity of both the engineering and the production and the changes, and it must have been a combination of unbelievably stressful and exhilarating. So reflect on that.
Yeah, it's interesting that you mention stress, and that's actually something that gets mentioned in some of these documents about this effort, is that this scale up was so incredibly stressful that it was very difficult for these managers to manage these new growing, manufacturing operations that were so much larger and so much more complicated than what they had managed previously. That some of them weren't just cut out for the task. It was beyond their capabilities to do. But some of them, it was just so stressful dealing with this that they had to sort of end up leaving because of health reasons. I think I read one statistic that at one factory, I think this was maybe the Lockheed for one of their aircraft, the P-80 that it was developed in like record time. But they also sort of mentioned offhand that something like 30% of the designers ended up making themselves sick because they were working themselves so hard to get this plane ready in time. And you just kind of see that, across the board. There was just this huge willingness to sort of, sacrifice and take on what needed to be done to get these things built and to try to win the war. I only mention him very briefly in the essay, but a huge a figure that was very, very important in U.S. wartime mobilization was this guy, Bill Knudsen, who was he had started out. He was an immigrant from Europe. He had started out working in Ford's factories and had sort of been one of the people that helped sort of work on the assembly line, the initial assembly line systems. And then he went and became the president of General Motors. And then he, at the request of President Roosevelt, he basically came and left his, very high-paying job at General Motors. He took a leave of absence and worked for $1 for the government to basically help them do their wartime mobilization. I think this was in 1940 is when he went and joined. And so a lot of the reason that the U.S. mobilization wasn't slower than it was because of Bill Knudsen, who basically he knew all the manufacturers, who knew what needed to be done to sort of get systems in place and how to build huge volumes of stuff. And so he set up the government systems that ended up managing this whole sort of mobilization. And I think he later left that role before the war was over. But, he was a Republican. The whole administration was Democrats. People kind of asked him, "Why are you going to do this? Why are you leaving your job at GM to go work for the government and basically make no money?" And he's like, "Well, this country has been very good to me, and I need to return the favor." And so he was that's just one example of many examples up and down the line of people who thought it was important to sort of do these jobs and figure out how to make all this stuff to win the war.
I mean, there's a certain sense of time that hangs over your piece because everybody's in a hurry. Nobody is dawdling, at least in theory. And as we look back on it 80 years later, it's like, wow, they really ramped things up. But it's hard to remember how long it actually took. And when you think about building a 6.3 million square foot production facility or an assembly line that's over a mile long, it took a long time. And of course, let's move it along. It wasn't your typical construction project because there was a war and people felt that something deeply important was at stake, but it can't be done quickly. It's done quickly relative to what it might be done in peacetime, but it just takes a while. You write, for example, I mentioned earlier, Willow Run. He said, you write, quote, "Nearly every aircraft produced during the war took more than a year to go from the 5th aircraft produced to the 500th aircraft produced." Meaning the first 500 the first one took a long time. Obviously, that's the design. But once you got a few made, you got to the 5th one. And then 500, it took at least a year. Then they got better at it. But then you continue. Even manufacturers familiar with mass production methods took time to ramp up. Despite the enormous amount of attention given to Ford's Willow Run factory that mass-produced B-24 bombers, its performance was mediocre at best. My aside, remember, this is the plant that eventually, by 44, is producing one an hour. But you write, quote, "For the first 2 years, the plant produced virtually nothing as it struggled with the difficulties of aircraft production, and the time it took to reach volume production was slower than many existing aircraft manufacturers. At one point, operations were going so poorly that the government considered taking over the factory. And while the factory eventually worked out its issues and produced aircraft in large volumes with impressively low labor inputs by the time it did so, it was too late. The Army no longer needed B-24s. What it needed were the larger, longer-range B-29s," end quote. So the complexity of this process under the incredible stress of wartime production, producing things that have never been produced before by workers who've never worked in this kind of facility, the stress and intensity of it must have been extraordinary.
Yeah, it's the whole thing is just incredible, and you often wonder to what extent the U.S. could accomplish something like that today if it needed to. Willow Run, to talk about that a little bit, is interesting because we talked about the sort of adoption of mass production style methods that were used in things like car manufacturing and what was needed to sort of modify them to work in the complexities of aircraft manufacturing. And what most manufacturers did, even the one, most of the airplanes were built by existing airplane manufacturers, but even the ones that didn't, most of them started by using traditional aircraft manufacturing methods, sort of the craft methods that they'd already been used to build airplanes. And then once they had learned those methods and learned what it took to build an airplane or an airplane engine, only then would they sort of like, okay, now that we know how to build these things, now that we know what it takes to, produce something with this level of precision and performance, now we will start to sort of bring in our knowledge of, automobile manufacturing and mass production and sort of adapt our manufacturing processes to these high volume production that we need. But Ford was almost the only one that just started to go right into sort of, car style mass production methods, just jump into that immediately without learning basically what it took to sort of build an airplane or an airplane engine first. And the result of that is that, they struggled for a very, very long time to sort of build anything in appreciable numbers. And it was going very, very poorly for quite a long time and the government was getting, more and more uncomfortable with how it was going. And they eventually figured it out, but it took them quite a long time to sort of get their production operations running along nicely.
I think about the managers in that plant going home again. About 43, they were doing this. 44, they were doing that. But night after night for 2 years, they produced nothing. Those were a lot of sleepless nights, I'd guess, right? That's pretty tough.
Yeah. You just look at, the arc of it is summarized by the statistics, you feel like you can get a sense of it. But, when you're in it day in and day out, and it's just, there's just one problem after another. It's like, oh, we can't get enough aluminum. Oh, there's a huge shortage of airplane gasoline. Oh, we're bringing in like 10,000 more workers to this plant. And none of them have worked in a plant before. And none of them know how to do a rivet gun, how to operate a rivet gun or a drill press or any of these tools. And all our workers that knew how to sort of operate these things are off, fighting in Europe or whatever. Just, the tidal wave of problems that was just washing over everybody constantly. It's just, difficult to imagine how hard it must have been.
And if I remember correctly, just that example you gave of the rivet gun, it was too heavy for many of the women to operate, so that they had to change something. What do you remember what happened?
Yeah, so traditionally riveting had been, done is sort of a team process where one person would hold the rivet gun and one person would sort of be on the other side. And these are like big, heavy, tools that needed a lot of strength to kind of manipulate, a lot of skill to sort of work. And so to allow women to sort of, or unskilled workers sort of operate these things, they had to sort of redesign them. They put like counterweights on them so it was easier to sort of move around. And they change it in such a way that could be done by one person. And so, that was another sort of big trend that you saw more broadly with these manufacturing is that, I talked earlier about sort of the staff, the production, the manpower chose the production process. They had to kind of redesign a lot of these tasks, a lot of these, actual specific things that the workers were doing, such that the workers that they had could actually do them. So, make things easier to do, make things so it doesn't require, 5 years of experience with a drill press to do the operation and things like that. So totally new tools, totally new like jigs and fixtures and support things that made it easier to sort of do all this stuff. Almost every job that needed to be done to put an airplane together was kind of redesigned to make it easier for sort of unskilled, physically less capable workers to do.
So 1944 comes, the war's turned, the Allies are doing much better. People forget the early days of the war were not so encouraging. People who are watching this on YouTube can see on my top shelf the 5 volumes of Churchill's memoirs of World War II, and he wrote those after. I think he wrote them, most of them after the war was over. But the early and middle days were not. Were dark. But eventually, the tide turns. The Axis, Germany, Japan, Italy are falling back. The Allies are on the march. And we come to this weird situation in 1944, the peak of production of 96,000 plus planes in the United States. And it's almost as if there are too many. They start replacing planes that they never would have replaced if they had any kind of problems, and just replace them with, just bring a new one. We got plenty. Talk about what happened then. What was going on, and what are some of the things that were done with planes at that point? It was almost a surplus.
Yeah, they were this, like you said, this production machine had finally ramped up and, producing airplanes in enormous numbers, like you talked about earlier, B-24 coming off the line every hour or whatever like that. And it was such an enormous flood of airplanes that, yeah, it had reached the point where they kind of didn't know what to do with them all. It was more than they could find immediate uses for. But they didn't want to, they had this big, beautiful production machine they could crank out huge numbers of airplanes. And they didn't want to turn it off because, they were still fighting the war. They didn't want to lose all this capability that they had to sort of build these huge numbers of airplanes. So they basically just started, finding ways to sort of make use of them. And one of those things you see is that if an airplane was slightly damaged, they would just all right, get rid of it. We're going to just bring in a new airplane because huge number ones are coming off the lines constantly. An aircraft comes back from, battle or whatever, it lands an aircraft carrier, it's slightly damaged, push it over the side of the aircraft carrier because we have new planes coming in all the time that we can just land a new one on and just forget about the sort of those damaged ones. There was I think islands in the Pacific where they dug up, they dug these huge pits and then just pushed huge numbers of airplanes into them and just compacted it down with tanks or whatever. Because again, these airplanes were coming. They didn't have any place to put them or anything to do with them. And at the very end of the war, you had the situation where, in some cases, apparently, airplanes were flying directly from the factory to these sort of junkyards, to boneyards, to sort of be disassembled or to go into storage because they didn't even make it their way to anywhere near resembling a battle. They just immediately went off from the factory to be junked because this machine to build these airplanes, it took so long to sort of spin up, and it took it didn't take quite as long, but it took a while to sort of spin down as well. So for a while, you were producing this huge numbers of airplanes that weren't really needed at the time when countries like Germany, countries like Japan were having a very, very, very hard time fielding any aircraft at all. At the same time, the U.S. is producing this such huge numbers that it can sort of basically trash the ones that they don't need.
And as you point out, most of these factories were in the Midwest, quote, far from the enemy, because everything other than Hawaii, almost everything was far from the enemy in World War II. But Germany and Japan were, of course, their production facilities as the war wore on were increasingly at risk of being destroyed by nighttime bombing raids and so on. So the disparity between Allied production and Axis production must have grown steadily to that point where they could push a plane over the side of an aircraft carrier. I mean, did that, my first thought is, did that really happen? Did it happen more than once?
Apparently, this is in one specific source that talked about the pushing it over the side. So it's not incredible. It's not a sort of anecdote that shows up over and over again in these descriptions of the historic manufacturing. But in general, it tracks to me just based on the huge numbers of airplanes produced and the time and effort it would have taken to sort of fix them in the field. It doesn't seem crazy to me.
So I think most people assume, and I think many historians assume, that the United States manufacturing success was, quote, inevitable. The United States was a very successful economy, even in the 1940s. And yet, you point out that this was much more complicated and uncertain at the time than we think about it in hindsight. This is how you close the essay. It wasn't until 1942, 3 years after Germany invaded Poland and France, and Britain declared war on Germany in response, that U.S. aircraft production truly ramped up. And even this was only possible because of enormous early orders from Britain and France and the work of far-sighted folks like Bill Knudsen, who knew how long it took to scale up manufacturing operations. Had events occurred slightly differently, the outcome of the aircraft industry scale up and perhaps the war itself might have looked very different. World War II aircraft production shows that it's possible for a complex manufacturing industry to grow incredibly rapidly, but it also shows the limits of that scale up, that even in an emergency, some things can only be accelerated so much, and success depends on what preparations have been taken beforehand. End of quote. Meaning, if it hadn't been for the French and British orders in 38 and 39, they had been more prepared, for example, the U.S. aircraft production might only have peaked in 1947 or 48, in which case the war might have been over and the United States might have lost. So I think what's powerful, I mean, I love your piece. I think it's an incredible compendium of incredibly fascinating facts. But the deep conceptual piece behind it is that this was such a complex process. It turned out well for the United States and the Allies, but it could have been different.
Yeah, and this is I think a larger debate among historians, among economic historians, is what extent it's sort of a flavor of like the great man theory of history versus, to what extent are you driven by like specific decisions of specific important people in key roles? To what extent is history driven by like large scale economic trends? So is it how much of the war is dependent on like the United States' manufacturing output versus and the rest of the Allies versus the Axis? And of course, on the eve of the war, the U.S. was the largest manufacturer in the world. I think it made more cars and more steel than like the rest of the world combined, more machine tools than anybody else. And so, you look at something like that and, maybe, you can argue that, or, maybe the data show that, it could have, bumps along the road, but the 30,000 foot view, it was inevitable that the U.S. would scale up its operations. It was inevitable that the output of those munitions and weapons and things like that would be so huge that it would overwhelm the Allies. Just the economic disparity, or the Axis, excuse me. Just the economic disparity was so great. And so I don't have a dog in that fight. I'm not well informed enough about sort of, details of, all of World War II and the various, production operations and decisions made by the various things. But so it's not necessarily obvious to me whether the winning or losing the war turned on like some of these or lucky breaks basically from the U.S. It could be true. It could not be true, and maybe the war just ends up getting delayed. Maybe the casualties, the winning the war ends up getting delayed. Maybe casualties are much higher than they would have been. Maybe the outcome is like slightly different on some margin rather than the war itself. The outcome of the war itself being different. So I don't know that per se, but I think it could have, obviously, not gone the way that it did with the U.S. winning in the 1945, basically.
My dad was born in 1930. If the war had gone to 1948, he might have been drafted. He might have been lost in the war. I might not be here. It's hard. You tend to think about, if the U.S. had lost or been taken longer, a lot of things, of course, would be different. Let's talk about the implications for today. There was an article in the Free Press recently arguing by Chris Power. Now he's a CEO of a defense company and a manufacturing company, so he's not the most objective observer. His claim, which I'm skeptical about, but it's provocative, is, quote, every great power in history lost its dominance when it gave up its industrial edge. The U.S. must act now to avoid the same fate. Many economists, and I've been one of them, have argued that we don't need, first of all, the United States still makes a lot of stuff. It's not like we don't have as many workers percentage-wise in manufacturing as we once did. That's fallen steadily since 1945, more or less. But actually, manufacturing output's very high in the United States. I've had a guest, Susan Hausman, who suggested a lot of that's computer production. It's not really that helpful if we ever need a few million drones or tanks again. But I've always suspected and argued that, well, okay, if we don't have, let's just say we don't have any car production. The United States doesn't have any car production and they need to make tanks. As unlikely as that seems in a war in 2020 something or 2030 something. So suppose we did need traditional weaponry that's used in war. Surely the United States could ramp up production of various things and not have to depend on its potential enemies for production. But maybe I'm wrong. And it certainly would be a terrible mistake to make. So what are your thoughts on that? Do you think that the United States should be, on security grounds now, not standard economic arguments, but on security grounds, maintaining an engineering and weaponry manufacturing capability because of the time that we've been talking about this in our conversation it takes to make these changes? Surely I'm sitting here in Jerusalem. Israel's very aware, Israeli leaders are very aware that even though the United States is an ally through much of this war in Gaza, the dependence on U.S. production of all kinds of things has affected Israel's conduct in the war. And I suspect there'll be changes in what Israel makes for itself rather than that it gets even from an ally, let alone an enemy. What are your thoughts on whether the United States should be investing in its own capabilities in these areas to make sure that it's not dependent on, say, China?
So, yeah, I have a few sort of scattered thoughts on that. One, I think I do agree that the U.S. sort of manufacturing capabilities have been, offshored, hollowed out to a very large degree. And so we lack a lot of the fundamental capabilities that would be needed to sort of scale up manufacturing quite quickly. An example that I'm a little bit familiar with is injection molding, which is basically a way of making plastic parts. You have these big metal molds, and they basically get filled with hot plastic into the shape of whatever it is that you're making. For plastic things, that's like a standard way of making anything in very, very large volumes. And the U.S. does do some injection molding in the U.S., but the actual making of the molds for those machines, which is a key bottleneck for manufacturing, is to actual make the mold itself for whatever part is you're producing. That is almost entirely done overseas. Most of it, very, very large fraction of it, is in China. But those, even companies that do injection molding in the U.S., they will sort of buy the molds or get their molds designed by overseas companies. And that's something. So that's like a capability that is really, really atrophied, and it's not something that we were able to scale up quite quickly in a moment's notice. And so if you need to make large volumes of like plastic parts for something like drones, that would be a pretty big challenge. And you see kind of similar things quite quickly. It took the U.S. or in other areas of manufacturing. It took the U.S. a pretty long time to scale up artillery shell production. I think that for a while, at one point that I looked, I don't remember the exact numbers, but the U.S. was supplying fewer artillery shells to Ukraine than to North Korea was supplying to Russia. So we were getting outproduced in artillery shell production by North Korea, which I think is a pretty stark illustration of how
seems alarming.
Yeah, how difficult we have of scaling up certain manufacturing operations. And so, it's I think we do lose these abilities, and it's not something that you can just, we still make a lot of stuff. If we needed to, we could scale up our manufacturing capabilities quite quickly. I think the U.S. at the time, World War II, was drawing on both its sort of huge manufacturing output in other areas, and sort of its muscle memory, its ability to just build things quickly. The late 19th century and the early 20th century, the U.S. was just very, very good at building very, very large amounts of infrastructure very, very quickly. That's when you have, building hundreds of thousands of miles of railroad, going from nothing to having a huge electrical grid, going from nothing to having, huge numbers of cars on the road, building things like the Hoover Dam, building things like the Empire State Building, going, mass urbanization in a lot of cities. And so the U.S. was just very, very good building things quite quickly. And it's not something that the U.S. is very good at today. We struggle with building very, very large numbers of, or very, very large, numbers of things quickly, very, very large amounts of infrastructure quite quickly. And so I think those are in some ways, that is what worries me more than the actual building of the physical stuff, is that we've lost the sort of muscle memory of how to sort of build this stuff quickly if we need to. I think that's what kind of gives me more pause.
So let's do a little thought experiment to close. You're a modern. You were born sometime, I'm guessing, in the second half of the 20th century. And I'm going to time travel you back with your current knowledge to Willow Run in those 2 years when they weren't doing very well. And I'm going to put you in charge. So that's one thought experiment. The second thought experiment is we don't have any factory making whatever it is we need to make, injection molding or some kind of drone. And I'm going to put you in charge of that. So you've got some muscle memory. You're a trained engineer, but you don't have you've never used the muscles that I'm going to ask you to use. Could you do it? I'm thinking about that subtle and customized form of bending aluminum around a improvised frame as they're assembling those B-24s in the beginning. Hard to do, but you're really smart, I'm guessing, and you've been trained in a lot of things. Are those things relevant at all, or just a little? Or would you kind of eventually maybe even pretty quickly figure it out in either of those two thought experiments, or are we cooked?
So that's an interesting question. So I think for the travel back to World War II, I think the main point of leverage where you'd want to go to sort of, make changes into sort of what the outcome and have a better, better, quicker scale up is not at Willow Run in 1940 or whatever. What you really need to go is back into the late, the mid to late 1930s, and need to go to the people in the government and say, we need a real plan for scaling up these manufacturing operations. Roosevelt needs to make his big declaration of building huge amounts of airplanes, not after Germany invades Western Europe, but he needs to make it, in the 1930s and come up with real plans for how specifically you're going to sort of make these huge numbers of airplanes and how the sort of existing aircraft manufacturers are going to scale up their operations and how they're going to sort of interface with all these other companies that have never made anything in the aircraft manufacturing industry before. So I think that's the important point of leverage, is it ended up not being so much of a question of like material and manufacturing processes so much. It was really a organizational and decision-making bottleneck that ended up being most important in the early days. And so what's important is to sort of maximize your odds of a good outcome is to sort of, I think, act on those points of leverage in the decision-making and institutional organization process. And I don't know if I would be very convincing to the sort of people in charge, but I think that's where you need to sort of make changes. And so something similar, I think, is probably true today. You need someone to have a real mobilization plan in place, a real strategy for scaling up to the huge numbers of output needed. I do not know if something like that exists today.
My guest today has been Brian Potter. His site is on Substack, Construction Physics. Brian, thanks for being part of EconTalk.
Thanks for having me.
This is EconTalk, part of the Library of Economics and Liberty. For more EconTalk, go to econtalk.org, where you can also comment on today's podcast and find links and readings related to today's conversation. The sound engineer for EconTalk is Rich Goyette. I'm your host, Russ Roberts. Thanks for listening. Talk to you on Monday.